Hello students, today we will see MCQ on electricity. So here is the first question. Which of the following units could be used to measure electric charge? Option A, ampere. Option B, joule. Option C, volt. Option D, coulomb. So here ampere is the unit of electric current. So that will be not the answer, and joule is the unit of heat, and volt is the unit of potential difference, right? So unit of electric charge is coulomb. Next question. The work done in moving a unit charge across 2 points in an electric circuit is a measure of. So the work done between the two unit charge. So current, it is the rate of flow of charges. Resistance, it is the opposition to the flow of current. And power is the product of voltage and the current. So here the option B is the right answer. The substance having infinitely high electrical resistance is called option A, conductor. Option B, resistor. Option C, superconductor. And option D, insulator. Here option A, conductor, through which the current easily will pass. So option A will not be the answer. So resistor, any material which offers the resistance, so that is called as resistor. Whereas superconductors, at a certain temperature, the temperature will not increase, so that will be the superconductor. So here infinitely high electrical resistance, the answer is insulator. When the diameter of a wire is doubled, its resistance becomes. So here the answer is 1/4. Okay, remember this one. Whenever we will double the diameter of a wire, its resistance will become 1/4, because the diameter and the resistance, they are inversely proportional to each other. So if we double, the resistance will become 1/4. Next question. If the diameter of a resistance wire is halved, then its resistance becomes option A 4 times, option B half, option C 1/4, option D 2 times. So the answer for this one question is it's becomes 4 times. It becomes 4 times. Remember this one. The next question. The resistivity of copper metal depends on only one of the following factors. This factor is option A, length. Option B, thickness. Option C, temperature. Option D, area of cross section. Look at here, we have resistivity of a copper metal. So here resistance will depend on length of the conductor, the thickness, and area of cross section. Here we have resistivity. So resistivity will depend only one factor. That factor is temperature. So here our answer is C. Answer is C. The unit of expressing electric power is option A, volt. Option B, joule. Option C, coulomb. Option D, watt. So the electric power unit is watt. Okay, because coulomb is the unit of charge, and whereas joule is the unit of heat, and volt is the unit of potential difference. So here answer is watt. Next question. Which of the following is likely to be the correct wattage for an electric iron used in our homes? Here actually we need to find the electric iron power. So electric iron power, it's 850 watt. Remember this one. Electric iron power, it's 850 watt. Next question. The SI unit of energy is. So here we have joule, the unit of energy, and coulomb, it is the unit of charge, watt is the unit of power, ohmmeter is the unit of resistivity. So the answer is joule. Next question. The commercial unit of energy is option A watt, option B watt hour, option C kilowatt hour, option D kilojoule. The commercial unit of energy is kilowatt hour. Option C is the right answer. Next question. If the potential difference between the ends of a fixed resistor is halved, the electric power will become option A double, option B half, option C 4 times, option D 1/4. So the answer is it's 1/4. The relation between the resistor and the power, it will become 1/4. Next question. An electric fuse works on the option A chemical effect of current, option B magnetic effect of current, option C lighting effect of current, option D heating effect of current. See, the fuse works on heating effect of electric current because this electric fuse is having low melting point. So as the current in our home exceeds the limit, it will breaks. So the circuit will break and we can prevent the damages to the electrical appliances. Next question. The elements of electrical heating devices are usually made up of option A tungsten, option B bronze, option C nichrome, option D argon. So the electrical devices, the heating electrical devices are made up of nichrome wire because nichrome wire, it is an alloy. So as it is having the high resistance, so all the heating devices are made up of nichrome wire. Next question. In a filament type light bulb, most of the electric power consumed appears as option A visible light, option B infrared rays, option C ultraviolet rays, option D fluorescent light. So here the power consumed appears as infrared rays. Option B is the right answer, infrared rays. Next question. Which of the following is the most likely temperature of the filament of an electric light bulb when it is working on normal 220 volt supply line? So the temperature is it's 2500 degree Celsius. So option C is the right answer. The next question. If the current flowing through a fixed resistor is halved, the heat produced in it will become option A double, option B 1/2, option C 1/4, option D 4 times. So the answer for the question is it's 1/4. 1/4 is the right answer. You just go through the relation of heat produced in a conductor. The relation is H is equal to I square R into T. You will find the answer. Next question. If the area of cross section of a resistance wire is halved, then its resistance becomes. Here the answer is 2 times. The resistance will become 2 times when the area of cross section is halved. The next question. The lamps in a household circuit are connected in parallel because option A, this way they require less current, option B, if one lamp fails the other remain lit, option C, this way they require less power, Option D, if one lamp fails, the other also fails. So the reason for combining the lamps in household is if one lamp fails, the others remain lit. So here the answer is option B is the right answer. The next question. The heat produced by passing an electric current through a fixed resistor is proportional to the square. Option A, magnitude of resistance of the resistor. Option B, temperature of the resistor. Option C, magnitude of current. Option D, time for which current is passed. So we know the relation that heat produced in a conductor, H is equal to I square R into T. So here the square is, that is option C, that is magnitude of current. Magnitude of current. Next question. The current passing through an electric kettle has been doubled. The heat produced will become. So the heat produced, it will become 4 times. Option C is the correct answer. Next question. Which of the following characteristic is not suitable for a fuse wire? Not suitable for a fuse wire. Option A, thin and short. Option B, thick and short. Option C, low melting point. Option D, higher resistance than rest of wiring. So here fuse, it is thin and short, it's absolutely right. Low melting point, yes, it is right. High resistance than rest of wiring, it is also right. So which is not suitable? That is thick and short is not suitable. So here option B is the right answer. Next question. Keeping the potential difference constant, the resistance of a circuit is doubled. The current will become half. Option B is the right answer. Next question. The resistivity of a certain material is 0.6 ohmmeter. The material is most likely to be option A, an insulator. Option B, a superconductor. Option C, a conductor. Option D, a semiconductor. So here the answer for this one question is option D, it's a semiconductor. So the resistivity value for the material is 0.6 meter. It is for option D, that is semiconductors. Next question. When the area of cross section of a conductor is doubled, its resistance becomes option A, doubled. Option B, half. Option C, 4 times. Option D, 1/4. So the answer for the question is it's half. It will become half. Next question. Keeping the potential difference constant, the resistance of a circuit is halved. The current will become option A, 1/4. Option B, 4 times. Option C, half. Option D, double. So the current, it will become double. So the option D is the right answer. Next question. 1 coulomb of charge is equivalent to the charge contained in option A, 2.6 into 10 raised to 19 electrons. Option B, 6.2 into 10 raised to 19 electrons. Option C, 2.65 into 10 raised to 18 electrons. Option D, 6.25 into 10 raised to 18 electrons. So here 1 coulomb of charge contains, it's equivalent to 6.25 into 10 raised to 18 electrons. So option D is the right answer. Next question. The other name of potential difference is amperage, B, wattage, C, voltage. Option D, potential energy. The other name of potential difference is its voltage. Option D is the correct answer, because here ampere is the unit of current, wattage is the unit of power, and whereas the potential energy, it's the unit of that is energy. It's a physical quantity. Okay. Next question. The unit of measuring potential difference is option A watt, option B ohm, option C volt, option D kilowatt hour. So the answer is it's volt. It's volt because the unit watt is the power of that is the unit of power, ohm is the unit of resistance, and kilowatt hour is the unit of electrical energy. Next question. Which statements is or correct? 1. Statement number 1. An ammeter is connected in series in a circuit and voltmeter is connected in parallel. Right? Second one. An ammeter has high resistance. Third one. A voltmeter has a low resistance. So here are the options. Option A 1, 2, 3 all are correct. Option B 1, 2 is correct. Option C 2, 3 is correct. Option D only 1 is correct. So here you look at here, ammeter it is connected in series in a circuit, and voltmeter it is connected in parallel. Absolutely right. We know that when ammeter it is always connected in series, whereas voltmeter it is always connected in parallel. Okay. And here we have second one, an ammeter. So here this one statement is correct. Okay. Second one, an ammeter has high resistance. No, ammeter has low resistance. Okay. And voltmeter has low resistance. No, voltmeter has high resistance. So here only option that is the only statement 1 is correct. So only statement 1 is correct. That is we have the option D is the correct answer. Next question. Which unit could be used to measure electric current? So option A watt, option B coulomb, option C volt, option D ampere. So to measure the current we use the unit that is ampere. Okay, the remaining volt is the unit of potential difference, coulomb is the unit of electric charge, watt is the unit of power. Next question. Ohm's law gives the relationship between option A current and resistance, option B resistance and potential difference, option C potential difference and electric charge, option D current and potential difference. So here Ohm's law will give the relationship between current and potential difference. So option D is the correct answer. Next question. The unit of electrical resistance is option A ampere, option B volt, option C coulomb, option D ohm. So the electrical resistance unit is ohm. Option D is the correct answer because here we have coulomb, it is unit of charge, volt is the unit of voltage, ampere is the unit of current. Next question. The device used for measuring potential difference is known as option A potentiometer, option B ammeter, option C galvanometer, option D voltmeter. So to measure potential difference we use the device called as voltmeter. So option D is the correct answer. You know that one remaining potentiometer, ammeter and the galvanometer. Galvanometer is used to detect the presence of electric current, ammeter to measure the electric current. Next question. The unit of charge is option A ampere, option B coulomb, option C farad, option D volt. So the unit of charge is here option B is the correct answer because ampere it's the unit of electric current, farad and volt, you know this one, these are not belongs to the charges. Next question. A body can be negatively charged by option A giving electrons to it, option B removing some electrons from it, option C giving some protons to it, option D removing some neutrons from it. So a body can be negatively charged, giving the electrons to it. Option A is the correct answer. So any body which takes the negative charge, so that body is negatively charged body. So here option A is the correct answer. Next question. No current flows between two charged bodies when connected if they have same. Option A capacity, option B potential, option C charge, option D none of these. See, no current will flows between two charged bodies when they are connected when they are having the same potential. Remember this one. Option B is the correct answer, because to move the charges there should be a potential difference. Okay, so here answer B is the correct answer. Next question. The surface of the earth is taken to be at infinite potential, option B negative potential, option C positive potential, option D zero potential. See, the surface of the earth, it is taken to be at zero potential. So the option D is the correct answer. Next question. Of the following groups, which one contains good conductors of electricity? Option A iron, nickel, cobalt. Option B mica, distilled water and ceramics. Option C copper, silver and aluminium. Option D diamond, ebonite and wood. So the good conductors of electricity, it's copper, silver and aluminium. Copper, silver and aluminium, as these are having the low resistivity, so these are the best conductors of electricity. Next question. The resistances R1 and R2 are connected in parallel. The equivalent resistance of the combination is option A R1 plus R2, option B R1 minus R2, option C R1 into R2 divided by R1 plus R2, option D R1 plus R2 divided by R1 into R2. We know that to calculate the equivalent resistance when the resistances are connected in parallel, the formula is 1 by R equivalent is equal to 1 by R1 plus 1 by R2. Just to simplify that one, you will get the answer that option C, that is R1 into R2 divided by R1 plus R2 is the correct answer. Next question. Three resistances of 4 ohm, 5 ohm and 20 ohm are connected in parallel. Their combined resistance is option A 2 ohm, option B 4 ohm, option C 5 ohm, option D 20 ohm. So you combine these, the combination of these resistances when they are connected in parallel, the combined resistance is, you just simplify these things, you will get the answer 2 ohm. So the combined resistance is 2 ohm. Use the formula 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Substitute the value, simplify that one, you will get the answer 2 ohm. Next question. State which of the following is correct. Option A joule into coulomb, joule is equal to coulomb into volt. Option B joule is equal to coulomb divided by volt. Option C joule is equal to volt divided by ampere. Option D joule is equal to ampere divided by volt. So here we know that the formula for potential difference, that is V is equal to work done divided by charge. So here what they have done, they have written the units of work done, unit of charge and unit of volt. Okay, now you just manage that one in correct proper way, you will get joule is equal to coulomb into volt. So here option A is the correct answer. Next question. Electric power is given by option A P is equal to V divided by I, option B P P is equal to I divided by V. C, option C is equal to, option C is P is equal to I divided by V into I. Option D, P is equal to V into I. See, here the answer is option D, that is power is equal to voltage into current is the correct answer. Next question, kilowatt hour is the unit of, option A electric power, option B electric resistance, option C electric potential, option D electric energy. So the kilowatt hour, it is the unit of electric energy. It is the unit of electric energy. Option D is the correct answer. Next question, the electrical appliances in houses are connected with each other in, option A parallel, option B series, option C a combination of series and parallel circuits, option D none of the above. Here all the electrical appliances in our houses, we will connect each other in parallel. So here the option A is the correct answer. Next question, 1 ampere is equal to, option A 1 coulomb divided by 1 second, option B 1 coulomb into 1 second, option C 1 joule into 1 coulomb, option D 1 joule divided by 1 coulomb. See, here we have the formula current equal to is equal to Q divided by T. So the unit for the charge is coulomb, unit for the time is second, and unit for the current is ampere. So here 1 ampere, when we will say the current is 1 ampere, when there is 1 coulomb of charges are flowing in 1 second. 1 coulomb of charges are flowing in 1 second. So here option A is the correct answer. Next question, a fuse wire is inserted in which wire? Option A live wire, option B in the neutral wire, option C in the earth wire, option D may be connected in any line. So fuse wire, it is always connected with live wire. So option A is the correct answer. Next question, which of the given statements is not true regarding the electrical setup for the verification of Ohm's law? Option A, the voltmeter is connected in parallel with the known resistance. Option B, the ammeter is connected in series circuit. Option C, the rheostat can only increase the resistance in the electric circuit. Option D, the single key is used to switch on or off the electric circuit. Here we have to find which statement is not correct. Okay, so the answer is option C, because rheostat can be used to increase or decrease the resistance in the circuit. Okay, so remaining option A, option B and option D all are correct in regarding with the verification of Ohm's law. Only option C is not correct. So hence our answer is option C. Next question, if length of a conductor and its radius is increased twice, how the resistance will change? Option A, resistance will remain unchanged. Option B, resistance increase twice. Option C, resistance will become half. Option D, resistance will increase 4 times. So the answer for this one question is the resistance will become half. The resistance will become half. Next question, materials having non-linear voltage current relationship are: option A ohmic, option B non-ohmic, option C batteries, option D capacitors. See, the materials which obey the Ohm's law, we will call those as ohmic, and which does not obey the Ohm's law, like that is here they have given materials having non-linear. Non-linear means does not obey the Ohm's law. So those substances, materials, we will call as non-ohmic. Non-ohmic. So the answer is B, that is non-ohmic. Batteries and capacitors, you know that one. Next question. Due to flow of positive or negative charges or both charges at the same time. Option A, electric current is produced. Option B, light is produced. Option C, heat is produced. Option D, air is produced. So whenever there is a flow of positive or negative charges or both at the same time, electric current is produced. Electric current is produced. So here option A is the correct answer. So that's it for the most important questions on the lesson electricity. Thank you.